Imagine sitting in a luxury private estate on a mountainside in Colombia, sipping your morning coffee, and suddenly, the ground begins to shake. On August 10th, 2026, a powerful magnitude 7.4 earthquake struck Colombia. According to Colombia's Geological Service, it was the largest magnitude earthquake recorded in the country during the 21st century. Now imagine a coffee cup, barely moving, inside a carefully engineered building. This isn't a documented account of a real event. It's a speculative architectural concept built around real modern seismic engineering technology. Today we'll explore how a private estate like this could theoretically be possible.
Even though this story is fictional, if you can turn these technologies into reality, they will beat even that imagination. As a result, you will feel much safer on this earth.
Earthquakes don't ask for permission. The magnitude 7.4 earthquake that struck near San Jose del Palmar, in Choc Department, on August 10, 2026, is, according to Colombia's Geological Service, the largest magnitude earthquake recorded in the country during the 21st century. Though larger earthquakes have struck Colombia in earlier periods, originating roughly 100 kilometers beneath the surface, early reports describe damage and evacuations in several areas. But it's important to remember, an earthquake's magnitude alone doesn't determine how much damage any particular building will suffer. Distance from the source, depth, local ground conditions, topography, the intensity and duration of shaking, and structural design all influence the damage at a particular site. Still, this raises a question that has occupied many architects and engineers. What if a private estate were designed to accommodate controlled movement, rather than transmit all of the ground motion directly into the structure? Let's look at the concept for one such. Imagine villa, built around the principles of modern, seismic-resistant design. In this concept, rather than transmitting ground motion directly from the foundation into the superstructure, the engineers apply a well-established, real engineering technique known as base isolation at the isolation interface between the foundation and the superstructure. This concept envisions layered rubber and steel isolator bearings, a technology genuinely used in some modern, earthquake-resistant buildings. During an earthquake, these isolators don't eliminate ground motion, but in a building designed this way, they can reduce and modify the acceleration and forces transmitted into the structure above, resulting, in principle, in far less shaking and acceleration felt inside. That doesn't mean the estate would feel nothing at all. Rather, it's designed so the impact of the shaking is substantially minimized. This concept also borrows the idea of flexibility associated with Guadua construction and reimagines it using modern structural materials, though no specific, verified engineering documentation currently confirms a titanium carbon fiber exoskeleton in practice. So this should be treated as a forward-looking, speculative idea. Tour and lifestyle, imagine design. Engineering is only half the story. Now let's imagine what kind of luxurious living space might exist behind a structure like this. Walking through the door, what strikes you first is a sense of calm, and the mountain view stretched out ahead. In this concept, floor-to-ceiling glass walls blend the interior with the surrounding landscape, a design intention aimed at keeping the view as unobstructed as possible. Then picture an infinity pool, its glass floor extending out along the mountain's edge. In this imagined design, a swimmer looks down onto an open view below, though in reality, the structural support of any glass-bottomed pool would require detailed structural, waterproofing, impact, and seismic analysis. Describing it as floating in midair is purely a visual impression, not an engineering fact. One striking feature of this concept is an imagined water management system. The idea is that if sensors detect the initial P waves with enough lead time, an automated system could theoretically trigger pool water to divert into an underground reservoir, a system intended to reduce hydrodynamic loads caused by pool water sloshing, although its effectiveness would require project-specific analysis for the pool supporting structure, reservoir, and drainage system. In reality, claiming that thousands of liters drain in a fraction of a second isn't credible without specific flow rate data, safety analysis, and engineering documentation. This remains a hypothetical idea, not a demonstrated feature. Given the remote mountain location, this concept also includes a helipad, though in practice such a structure would likely require aviation, zoning, and environmental approvals, depending on the jurisdiction. It's also worth noting that any real mountainside estate would require its own geotechnical analysis for landslides, rockfall, drainage, and slope stability, risks separate from the shaking itself. Deep within the main structure, the concept includes a hypothetical emergency room with a separately designed foundation, potentially equipped with supplemental air filtration and satellite communication such as Starlink-type technology, though a separate foundation alone wouldn't make a room earthquake-safe, and any satellite connection could be disrupted, depending on power supply, sky visibility, and network conditions. So always connected can't be guaranteed. This is a concept for a home designed with earthquake resilience in mind, but no design eliminates disaster risk entirely. Engineering explained. So how could a private estate like this theoretically reduce the impact of a major earthquake? Let's break down the engineering behind it. First, base isolation. In this conceptual design, rubber and steel isolator bearings are installed at the isolation interface between the foundation and the structure, a real, well-established engineering method. When seismic waves hit, these isolators alter the building's dynamic response and can substantially reduce the acceleration and forces transmitted into the superstructure, though not down to zero. Second, a flexible structure concept. Guadua has a long architectural tradition. In Colombia, and properly designed bamboo structures can use flexibility and ductility as part of their seismic behavior. This concept imagines translating that same principle into modern materials, such as titanium or carbon fiber, allowing the structure to flex slightly under pressure and disperse energy. Ductility and energy dissipation are legitimate seismic design principles, but whether this specific material combination has actually been applied here remains unverified and speculative. Third, an automated seismic response system. If sensors detect the initial P waves with enough lead time, an early warning system could theoretically activate. This is real technology, but it detects an earthquake after it has already begun, rather than predicting it. Available warning time varies by location, distance from the source, and system design, and in some places, especially near the epicenter, the useful warning window can be very short or non-existent. This concept imagines using that window to divert pool water and automatically shut off gas and electrical lines. Gas shutoff, electrical isolation, and backup power would need their own dedicated engineering systems. They aren't automatically provided by earthquake sensors, and real-world evidence for this specific application doesn't yet exist. These systems, if properly designed and integrated, could reduce some forms of earthquake-related damage and risk, but that's no guarantee the structure would remain completely intact. Most people build a private estate for ordinary living. This conceptual villa is designed with the goal of reducing the impact of a severe natural disaster, drawing on established seismic isolation principles, alongside several speculative design ideas. No estate can eliminate earthquake risk entirely, but sound engineering design can meaningfully reduce damage and risk, paired with a mountain view that thoughtful, earthquake-conscious design is intended to preserve. So, would you want to live in an earthquake-conscious estate built on a mountainside like this? Or does the idea of living on the edge of a mountain make you uneasy? Let us know in the comments. If you want to see more incredible architectural concepts and luxury design ideas from around the world, hit subscribe.